Hello. Good morning, good afternoon, good evening. How's it going? Welcome to this very special stream. Thank you so much, everyone who's joining us. I'm going to give some of you folks a moment to get your water, grab your coffee, do that bio run. Thank you for being here. I'm Andrea Griffiths, a la Colombia dev in all places. And I am so excited to be here today because this is one of the best parts of my job, friends. I get to invite cool people to talk about things that I'm interested in when they give amazing talks and I'm busy to watch them. So I had the privilege of meeting Julia, our wonderful presenter today at We Are Developers Conference a few months ago. Gosh, was it last month? I feel like these 2 months have just kind of mashed together into one. And I wanted to go to her talk. I didn't get a chance to go to her talk. But then I figured, well, Andrea, instead of being selfish and just watching the talk to yourself, how about you invite Julia and then all of our GitHub community can get to watch it. So that's what we're doing. Welcome, everyone. Thank you for joining. We have folks from Peru, from France, from India. Thank you for being here, Priyanka. Thank you, Rahul. What's up? You give everyone a little more time to join in. Tell me something good. What's been going great? I'm just coming back in office from having a couple of weeks off, and I'm feeling cobwebs. Cobwebs need to be dusted. So, what did I miss? How many new models are there? I mean, I haven't been that fully disconnected, to be honest. But what internet drama did I miss? The tea. The tea. All right. Welcome, Ian from Switzerland. Thank you. All right. I think we'll just give folks a chance to join. If you haven't shared this on LinkedIn or on X, or if you're watching us on Twitch, take a quick moment and share with your friends, please. They too want to learn from Julia today. Welcome, Michael Brigada, for being here. All right. So for those of you who are just joining, I'm Andrea Griffiths from GitHub. Today's live stream is all about AI-powered modernization, and we're going to be talking about COBOL. And I would love to know who of you in the chat actually know what COBOL is. I think we have a lot of folks in tech. I mean, it doesn't take to be that new in tech to kind of wonder what COBOL is. So quick context, right? For those of you who are wondering what COBOL is. Well, let's do quick context with a contest. Let's see in the chat, how old is COBOL? And listen, friends, I had to Google this, okay? Or ChatGPT, what do we say nowadays? Yeah, I didn't know. I did the math and I say older than me. Let's see if someone gets it right. I'll tell you, it's older than 30 years, older than 40 years. But for those of you who are wondering, COBOL is still processing a ton of stuff. There is ATM transactions, a lot of financial processes powered by COBOL. So there is something like, I don't know, 200 billion lines of code running banks, insurance companies, government systems. And so what happens with this programming language that is, I'm going to give you the answer, 65 years old, right? In today's software development lifecycle, in today's companies, what is the challenge? What do you do? How did you find, not to be morbid, but legit, the COBOL developers are dying. So how did you find developers who know how to use this? And finding one, I'm sure it's like finding a unicorn. Lucky for you, I got an amazing unicorn with us today, Julia Kordick. Julia Kordick is a software global black belt at Microsoft. And we're going to ask Julia what a software black belt is because it just sounds amazing. It's like a code ninja, but better. Julia helps large scale organizations accelerate their developer workflows through pragmatic platform engineering. She's an excellent presenter. I've had the pleasure of actually, she was kind enough to come and help me facilitate a workshop, and I seen her in action, and her wealth of knowledge is incredible. She's got full stack experience. Is done it all: software engineering, dev lead, cloud solutions architecture, and knows how to bridge technical and business sides without losing anyone on the transaction. Today, Julia is going to be showing us some live demo action of migrating legacy COBOL using GitHub Copilot and autonomous agents, which is wild. So even though there are not many unicorns who understand COBOL deeply enough to do full migrations, we have GitHub Copilot and autonomous coding agents that can help us do that now. So Julia's going to show us how she's going to achieve code transformation. And listen, whether this is relevant to you and you don't have any COBOL systems you have to worry about, I guarantee you in the near future, there will be conversations about business value, modernization. And this is how you can be the unicorn for your company, understanding how to lean into the technology that we have, like GitHub Copilot and the coding agent, and you can be the star. So listen, Julia, you are the best. Welcome for being here. Thank you for being here, girl. I told you, like, my coffee is not kicked in.
Thank you so much for the nice words. I was sitting in the backstage and hearing you saying all these nice things about me, and I'm so flattered right now as I'm really red in my face. Thank you so much.
It's all truths, okay? It's all truths. So I'm looking at we have an amazing audience on the chat. Thank you everyone for being here. Folks from Italy, from Mexico, Simon, you're the GOAT. Simon learned COBOL 40 years ago. Wow.
Quite some time.
I mean, this is impressive. And Patrick, you said it, and you could not say it better. And tech years, yes, every year is now a million. So like a million tech years. Wayne learned it in the 80s in high school. Oh, that's what's up. And then 1994, you're one of the newer ones. But let's get started, Julia. First of all, before we get into the content that you so kindly prepared for us, love to know what a Microsoft Black Belt is. Like, can you tell us a little bit about that?
Yeah, of course. So Microsoft Global Black Belts are basically people who are just subject matter experts for a certain kind of field of expertise, right? So as you said, my title is like a software global black belt. So I'm one of the persons who's like very like seasoned in software engineering, DevOps, and obviously AI assisted coding as part of that. And this is why I got deeply into like the whole space of GitHub Copilot, of course. How can we use GitHub Copilot to actually code better, also in the more complex fields, right? Not only for test generation, obviously also for test generation, but also for so much more. And I never learned COBOL actually. And this is also like kind of the fun part. How I got into this project, because I was working in finance and banking before, and when I was just a little small software engineer back like 10 years ago, I was working at a health insurance, and they were still deciding. It was like 2018 if they run it when they write a new batch job, if they write it in Java or they still write it in COBOL. 2018.
Okay, wow. And this is back. Okay, I mean, which is now. I mean, almost 10 years ago. Like it's coming fast. And so you've been in the space, you didn't learn COBOL. Talk to us through this. Like, let's get into it. I think folks are eager to learn.
All right. So what we tried to, so when this whole idea of Gen AI appeared, right, I had like a colleague, Gustav, who's also a global black belt at Microsoft, and we were thinking about how can we actually use AI to solve this problem that has not been really solved yet, right? So there are a lot of like big partners out there, like an Accenture or a Kyndryl, who are basically doing mainframe modernizations for large organizations for years, but they are doing it with men and women power, right? So they have like developers who understand COBOL, and they have auto code generation to actually try to accelerate this modernization. But the whole part of the reverse engineering and what is actually going on in the code, they did not really get. So the auto-generated code obviously looks like auto-generated code looks like, right? It's not human readable at all. Doing maintenance on it, it's it's just messy. So we were thinking about, why can't we not do it better when we have like a tool like GitHub Copilot, for example, who is very, very well served in how to actually write good code. And then we were trying to think about, all right, these COBOL files, sometimes they have like 10K lines of code, so which is massive. So how do we actually put that into some kind of a context window? And the very, very early experiments that I did were end of 2023 at an automotive organization, where back then GPT-4 was still a thing, right? Just GPT-4, and I don't really know what the token limit was, but it was not that big. So, but we tried to actually break down step by step what we actually want to do. And I also wrote down what the steps are that we actually want to do, and I want to share it with you all. Share my screen, share my VS Code, where I have a slides.markdown, because I do not want to bore you with any slides at all.
Hero, thank you.
So we were looking at legacy code, and this is not only true for COBOL, this is basically true for every legacy code that we have out there, and we quite have a lot. Sometimes the code that we write 6 months ago is already legacy code, right? So we were thinking about, how can we actually try to break down the steps, what we need to do to legacy code to make it easier understandable for us, and also maybe more easy understandable for AI, right? Because the tokens are still limited, although we now have agentic AI, and we can also orchestrate this agentic AI. And we narrowed it down into like three basic steps that we have. The one is like code preparation. So the first is like reverse engineering. The first step is obviously the most problem with legacy code is that the organizations have actually no idea what this code is still actually doing. They use it, and they obviously use it for good, and oftentimes like very core systems that they use, but what the code itself actually does is kind of a mystery. So at first we need to actually break down what it's actually doing. So it's like a mixture of truth that is in the code, right? Subject matter experts that maybe are still in our organization, younger or like older ones, like these consultants that come back from retirement and help these organizations to still get making sense of that code. Maybe we have some separated kind of technical documentation or user handbooks, or we maybe have still users working with the application so that we get to know what it's actually doing. And we try to actually get it out of the code. And obviously we can also do this with GitHub Copilot, right? I prepared like a reverse engineering prompt. And what it actually now does, it tries to look at my COBOL code and trying to actually make sense of the information that's inside of that. While GitHub Copilot is working, I would just go ahead with the next preparation step, right? So the next preparation step for AI understanding would be, as the token window is still limited, we maybe want to get rid of information that is not relevant for AI, right? So for example, sometimes, or back then, it was kind of a common doing that you have logs on top of code files, right? Because we did not had any versioning back then, or like very early versions of versioning. So we actually wrote down into the files itself who touched it, when the person touched it, and what the person actually did, hopefully. And sometimes there's useful information inside of that, but sometimes it's also just I was here and I did nothing, right? But I saved this file some kind of new. And obviously this information is nothing that would add value for an AI. It would just confuse it. It would overflow the token limit. So we maybe want to remove it. Or we have like these comments over, like, there's like this meme out there, like when you have like the picture of the cat and there's like a little snippet on top of the cat which says cat, which is like usual comments in code, right? And we obviously want to remove something like that. And this would be actually something that would help. Another thing was, and this brings me actually to who we actually did this project with, which is like a customer that is Bank Data. And Bank Data is like a financial services provider. So they provide services for Danish banks. And they were so kind to actually collaborate with us on this project when we're doing like the third second and first iteration of this actual project. The problem is, as you can think of, the code is actually written and commented in Danish, and not many models are very good as seasoned at Danish. And we already know from statistics that models work better because they have a certain language bias when the information that are provided for the model are provided in English. So another step that we actually would have maybe need to take, if you're coming from Germany, it's the same, the true for Germany, for Norway, for all these kind of smaller European languages that are very specific, is that you maybe need to translate it to just make it easier digestible for the AI, right?
Mm-hmm.
We see GitHub Copilot is coming to a conclusion right now. It's kind of, all right, let it write, and we will go on into the next step before we look at the output. The next step would be actually enrichment, right? It's the completely opposite. Sometimes it's actually needed that we add comments to code so that we understand this code better. This could be another step that we could actually take, and we could obviously also ask GitHub Copilot to help us with that. So I obviously prepared also a prompt from that. We could add comments. Then obviously how COBOL is, we can actually open a COBOL file for a bit that we can see what I'm talking about here. Obviously, COBOL, I'm making it a little smaller, has also some it's highly deterministic. It's a programming language, right? So,
Right.
and if we have deterministic structures, we can try to work with these deterministic structures to actually help the AI, or also ourselves, to make sense of that code, right? So these comments with the stars, for example, or there's is also sometimes some kind of sectioning, or a section keyword inside of COBOL files. These are all little helpers that can actually also help the AI to actually do a useful chunking, to kind of do a useful chunking to actually make sense of the code. So we could also ask GitHub Copilot to identify these recurring deterministic structures to actually help us getting an idea what is going on in our code and how it's actually structured. And the third thing is actually what we learned is document everything. As you can see, as you have maybe already spotted, GitHub Copilot created me a markdown here for all the results that I just generated out of the business logic analysis, because we learned that sometimes using the COBOL code itself as a source for AI is still too overwhelming, because it's just too much information, and the information is kind of messy or not really restructured, especially when we do not apply these preparing steps. So a good practice that we already figured out is everything that you let Copilot generate as a preparation, write it down as a markdown file, so that it can actually reference these markdown files as source of truth, and only can use the COBOL code or the legacy code itself as a fallback if there is some kind of ambiguity inside of it. Going back into my slides. Whoops.
I have a quick question, Julia, if you mind. So two quick questions, actually. One, will we be able to see your actual prompts? Is there a GIF somewhere that we can take a look at it for the folks who want to go experiment with this?
Of course.
Awesome.
We have a full repository. I haven't pushed the prompt yet, but I can obviously do it immediately afterwards, after the stream. I have a full prompt little library here. Obviously, these are work in progress, but we can obviously look also right now in some of it, right? Or let's go into the reverse engineering, which we actually executed, where I ask it to actually extract the business logic of the COBOL files, and include technical documentation, comments, and user handbooks if they exist. And then I basically instructed to write it all in markdown files, that it should be thorough and ensure that all relevant information is captured. And I always add stay precise, but especially when we are working with a model that we prefer that is a little bit more talkative, how I learned. Also, the markdown files get extensionally bigger. So I asked it to be precise. But as you can see here, I'm working with the Claude Sonnet 4, which is currently my favorite coding model at all. And it usually is already kind of precise.
And that was my second question, and you answered it. The instructions for it to generate a markdown file with the findings or the analysis are part of the prompt itself.
Yes, they are part of the prompt itself. Sometimes it actually gets to it. It gets on the idea itself, but I actually actively wanted to do that, to doing like this documentation part, because it's actually so useful. And it also is like, because all the time when we are in legacy modernization, we have the problem that there is no real truth, right? There's usually nothing we can actually fact check what we are doing. So the only chance that we actually have is that we have humans that actually look into the in-between results and have like an educated guess if what we are seeing actually makes sense. So in the example of bank data, we actually had like engineers with us in like a little hackathon that we did together, where we were actually generating Markdown files and also immediately Java, and where we could check immediately with these engineers from the COBOL part that they actually that they provided for us, if it would make sense, or if the prompting of the agents, I will show like the prompting of the agents in a bit, if it is like, if we need to reiterate on something like that. Yeah, so I talked about preparation, I talked about enrichment. GitHub Copilot agent mode is currently doing wild things, but we'll just let it work for now, right? And going a little bit into like the next part, which is like automation aids. And these automation aids could also be used for AI, but to be honest, it's more for us as humans, right? Because when you are in COBOL, you have what we call like a call chain structure. And this call chain structure basically is like a graph, right? Which file is calling which file, which subprograms are they actually jumping to? They're jumping back, they're jumping forth. And this call hierarchy is also then always connected to like the whole like structure of the files. So having like it's actually done. Nice. So, and this call structure, so when you have like a 10 file call chain, this is already short, right? So like a usual call chain in COBOL files or in a COBOL program is between 15 and 25 calls that you do with some kind of a call chain. So all these files need to be also included inside of the context to actually make sense out of this call chain, which is massive. So how would we actually do that? So we try to generate like this call chain hierarchy so that we see who's calling who. And obviously, to support us here, we could generate a mermaid file out of that, right? So that just also that we as humans can kind of make sense out of that. Then obviously tests. I joked about tests earlier, but obviously tests are super important. But tests for COBOL, they're even more rare than COBOL developers these days. So the whole idea would be maybe that we try it in a like a TDD approach. So when we actually want to migrate from COBOL or from something to Java, we could try to extract the business logic, how I showed or explained earlier. We will look at the result in a bit. And then trying to follow like a TDD-driven design to ask it, okay, now you have the business logic, generate me all the Java tests that you actually need to verify this business logic. And on top of that, we can then start to generate actually the Java code, for example, which could also be suitable. But obviously, when you still have tests for your mainframe code, good for you. You should make use of that. So also including that into the context to actually help GitHub Copilot making sense of these information, or also like the whole framework that I will also show in a bit. And last but not least, back then, 60 years ago, there was nothing like libraries or third-party dependencies how we are today are using, right? So no one today would write a date time function by themselves anymore, right? So this is a solved problem. But back then, obviously, this was not a solved problem. So the people all wrote basically their own utility classes. And as we all know, utility classes can be very extensive, right? Because it's all like the nitty-gritty and the small things that we actually want to do. And obviously, an educated guess, like at least half of the COBOL code that we have is not business logic, it's actually utility classes. So when we have already like an estimated or like an educated guess about the business logic, we also have an educated guess what are utility classes that are actually in our COBOL files included. So we could also ask the AI to actually reason over it, typical functions to actually what could we then use as a dependency in a Java or like in a .NET as a result, and also like reduce like the whole amount of code that we actually also need to consider. We cannot like get it out completely because it's still part of the call chain, but we can kind of help the AI to make a little bit more reason or make a little bit more sense out of it. All right. In between it was doing wild things. I was watching it a little bit on the side, but let's have a look into our business logic analysis for now. It basically created me like a whole idea. And it actually got that right. As you can see here in my COBOL files, I used basically two parts of two different like COBOL files because I wanted to show you different kinds of COBOL. So these listings .COBOL files are part of like a COBOL learning book, and it basically shows how you can do a list in COBOL. And
Wow.
this COBOL file is like from another project, which is from an AWS example that is open on GitHub. It's about showing some kind of, it's like a full mainframe program that they just provided open source for us. So I was thinking, why not make sense of that? And this is one kind of a file that has like, let's have a look how many lines of code it has, 1,500. So it's not the biggest COBOL file out there, but it's also not the smallest, right? While these have like 100. And it actually got that, right? So that we have like two different kind of COBOL files. It gives me like a whole file inventory, and it also did some kind of a result, how much the complexity is. So obviously it got that this is like the highest in complexity, makes some kind of sense out of it, and trying to also make sense of the business purpose. And if I would now have like an engineer with me from that organization who is actually working with that kind of program, they could help me making sense if the AI is on the right way here. And this is nothing multi-agentic we did here right now. This is only GitHub Copilot agent mode, right? This is already super impressive. You still saw all the time on the side, it was working really, really hard. And it also asked me in between if it should continue because it was working so hard. But it is the good thing with AI, it does not really need a break, right? Yeah. And it also gave me already a mermaid diagram, which is kind of cool. And then basically helped me making sense of everything that I got here, which is like a good starting point. And I obviously could now just take this business logic file, if it would be accurate, and start generating Java code out of that, if I would like that, right? And this is just the power of GitHub Copilot. Yeah, and this is basically how you would approach that. And for all the steps that we just talked about, I have here like example prompts written down. I can push them in the repository a little bit later. So if you want to actually access the repository, we also have like a shortcut for that, which is like, where is it? Is it gone? Oh no, here it is. The repo can be found under aka.ms/COBOL. And we also wrote like a whole blog article about everything that I already talked in like these 28 minutes about, where we're also talking about that, which is aka.ms/COBOL-blog. So you can basically see about the whole story, how we approached like the whole problem, all the steps that I just talked about for preparation, enrichment, and automation aids, and also what we then did with Azure AI to actually go beyond GitHub Copilot, because we noticed that GitHub Copilot is really good in this part of the preparation, which is true for all the legacy code. But what a lot of our customers were actually looking for is some kind of a silver bullet solution, which does not exist, right? So everyone who's currently promising you, hey, I can solve all your mainframe problems with just one click, this person is lying to you. Don't believe these persons because the complexity is still so high. And we are still, although we are already advanced in the whole agentic orchestration part, we are still not there, right? So we are very early in the whole agentic journey. I think we will maybe be able to solve it in 5 years, but we definitely cannot solve it now. So whoever is promising you we can solve that automatically without the help of any human interaction, this is not the truth. But you can try yourself, at least in iterative steps. And this is actually how my colleague Gustav and me actually created this kind of project that I'm currently working on with these like COBOL source files. What we want to do, I will close GitHub Copilot. Thank you, GitHub Copilot. You did a very well job for this demo. What we actually did is we created this kind of repository. together with bank data. And what we actually wanted to do is we were using Microsoft Semantic Kernel, the Semantic Kernel SDK, for agentic orchestration. We tried AutoGen before. I don't know if you're also familiar with AutoGen. It was one of more early approaches of agentic automation, which is based on Python. Because I'm not a .NET developer. Although I work for Microsoft, I never wrote a serious line of .NET in my life. I'm coming from the Java world, which is like this where I'm coming from banking, right? But Gustav was, luckily. So the first steps that we did was actually with AutoGen, who was written in Python, but it was just not advanced enough for what we actually wanted to do, because we needed like a high capability orchestrator, and this is how we went to the Semantic Kernel SDK then. So if you're also experimenting with multi-agent orchestration, Semantic Kernel should be like a project that would be interesting for you as well. And as we had like this use case from bank data, they wanted to go from the COBOL that they have to Java Quarkus. So this was the first use case we were actually looking at, but we tried to write this framework that you can basically prompt the agent from every source that you might have in your organization to every target that you might have in your organization. It's just depending on the prompting of the agents. And yeah, what you need is basically an Azure OpenAI endpoint or an AI endpoint of your choice. When we started experimenting, at first we started with the 4.0 model, but then we noticed the 4.0 model was way too talkative, how I mentioned before. And it also was not very sufficient with managing like overflowing tokens. So we experimented a lot with the 4.1 and also with the 0.1 and the 0.3 mini. And these are models that I can currently recommend you if you want to try this project. Try it with a 4.1 or an 0.3 or an 0.1 mini. Because we also noticed at a certain point, the 0.1 mini actually has some kind of COBOL knowledge in it, while the 4.0 was hallucinating a lot. The 0.1, yeah, we don't know, as we don't know what is actually baked into that. Yeah, we were kind of surprised, pleasantly surprised in that case, because the results were so much better in these test runs. Yeah, you basically need an endpoint, and then we created like this doctor. We can undo at least this doctor.sh, which basically leads you to everything that you need to know. So let me close it and just show it to you. Opening my README again. What we want to do is, so we have like this where is it? Doctor.sh, and we can actually let me check it, because I'm a little nervous and I forgot the command. We can have like the doctor command.
Okay.
And it's then checking at first my whole like the whole like configuration, right? It checks, all right, do you have like an endpoint defined? Do you have all the variables set that you actually need to do? Do you have like a thoroughly documentation in the README so that you can see what's actually going on? It tells me, okay, my configuration is successful. And then I can do actually also like a test. And then it's checking if also all the dependencies that I need are actually installed. In this case, like the whole semantic kernel. As you can see, there are only warnings, there are no errors, so we are absolutely good to go. The project was built successfully, and what it now will do is it will actually take everything that I have pasted down in this COBOL.source folder and will try to actually generate Java Quarkus out of that for me. So when I now do Dr.sh run, it will actually pick up everything that it has here, and it will tell you basically everything that it does all the time. So you can follow it in real time in the terminal. So the longest one that we experimented was like 12 hours. So as you can see, I'm working in a code space here because I obviously don't want to have like the full load on my local machine, where it's also like a code space is perfect for, right? And it now will take basically everything, and it will tell all the time. We will see which agent is actually talking. The first, we have like the dependency mapper agent, which is like the whole like creating like the call chain structure I talked earlier, having also a look what could be already like dependencies that we know of that we maybe don't need anymore, or could be like third-party libraries. And then we also have like the COBOL analyzer agent who is then going thoroughly with the GPT-4.1 into like the COBOL files. And it also tells you all the time, because a lot of customers are then like concerned, all right, we are now starting agents working autonomously with an endpoint. How much will this actually cost? We actually implemented here that you see how much the call actually took, how many tokens it actually took, and what it actually costed on an estimated basis, right? And then it will basically walk itself through all the COBOL files. It will give you like a whole like rundown where it's actually currently working on. And obviously it's not doing it on its own, right? So we have like the prompting of the agent itself, which we can also look into a bit, but we also generated basically a COBOL in the Copilot instructions file, which has also been taken by the agents. We just thought it would be convenient if we have like basically everything in one place for like the system prompt, which is like the basically the same that we can also see in bit. Now I need to find the program.cs and trying to find our analytics agent. Where is it hidden? COBOL. Yeah, it's all live, right?
Of course, of course.
Analyzer agent. There it was. I lost it. COBOL analyzer. Ah, there it is. There it is. And there you can see we have like the initialization of the agents. And we see here like the basic system prompt that we're getting for them, right? We want to have them like analyzing the COBOL code structure and the patterns. And going a little bit deeper, do we have like the thorough prompting somewhere? Not here, as it seems.
Sign up.
Yeah, having a look into that. The COBOL agent, it's written down. It's here. All right. And here you can see like the prompting for the COBOL analyzer agent, for example, going a little bit, where do we actually have it? It's in the folder agents. I could have get to that, right? All right. So we have the agents folder, and here we have like the whole like system prompt for the COBOL, for the agent itself, right? So, and as this is like currently very specific from going to COBOL to Java Quarkus, obviously this can be like adjusted to your personal needs. Maybe your COBOL is super special in some kind of way, so the COBOL analyzer could be actually adjusted, but it's obviously also same for the Java, or like the Java converter agent that we have, or it could be your .NET converter agent, right? And it always has like a system prompt. We give it like the persona of an expert in its field of expertise. And we give it like a basic prompt, what we actually want to do, doing like this COBOL analyzer, or like this COBOL conversation, and giving it basically a step-by-step instruction, what we as developers would also do. So when we would be in the unfortunate situation that we would have to convert from COBOL to Java, we actually would probably also like kind of follow these steps, right? At least we would create a Java class structure from the COBOL files. We would think about what data types we actually want to do. We want to transform the procedures into Java methods, all these things we just write down here. So this is like work that we have already done for you. You can just take it from here. It's an open source project, right? And we are also, by the way, we are very eager if you're opinionated on this framework, if you want to collaborate, or if you're even working in a customer field that maybe wants to talk to me and Gustav about how to collaborate on this further, reach out to us. We're very eager to looking also to other real COBOL files out there in the wild, because currently the bank data colleagues are the only one who actually provided us COBOL code, which we are very thankful for, though, because we would not have reached it without them. Yes. as you can see, we also have like the sanitized COBOL function here, which is also doing stuff that I prepared, that I explained earlier, right? This is all baked into like this open source program. But obviously, if you don't want to use like these tooling or functions, you could also just do it with GitHub Copilot beforehand. You just then have then less automation, but you obviously, the less automation you have, the more you are in control. It really depends how your engineering culture is actually in your organization. Because I learned, especially like larger customers, they have like this natural skepticism against AI, which is, I think, reasonable.
Fair, yes.
Totally. So for them, it would be actually more suitable to do it by hand or manual with GitHub Copilot beforehand, but just giving everything to AI, maybe. Looking a little bit into our analysis, we are now already at 90%. So actually, while we're waiting for it to finish, do we have maybe some questions in the chat already?
I have all the questions,
but do you have questions?
But I'm gonna be not selfish and take a scroll through the Slack, to the chat, and to the back scroll and see. I think just a lot of comments about COBOL. It was questions about maybe the I guess that pathway to modernization, something about being. And thank you, Purnima, for being here and interacting in the chat. It's functional modes from COBOL to cloud, or is other way also in reality for implementation requirements? I guess you could go from cloud to COBOL. There might be a new a scenario where that needs to happen. That I don't see that being like.
In the end, so back then, when COBOL was, or the mainframe was created, it was super suitable for the use case that it actually took, right? So this real-time processing of data, this mass data transformation, like the rollback mechanism that will build inside of that. But a lot of the code, so for these use cases, we cannot treat every COBOL code or COBOL program the same way convertible as all, right? We also wrote it down into like the block file because the non-functional requirements are maybe not met that easily in a cloud native structure. So we also need to think about like an design for like a cloud native, right? And this is something AI cannot currently do for us. For that, we need smart cloud architects to actually help us with that. This is obviously also true when you're working with distributed system on your on-premise system. It's not even about the cloud. It's just about the non-functional requirements of like modern application structures. But another truth is that when the mainframe was already there, a lot of like programs were written for a mainframe that does not actually need to run on a mainframe. So it was more like of a convenience that they had the developers, they had the infrastructures. There's code running on mainframes that does not need to run on mainframes, actually.
I appreciate the way that you went about the project, in that you have both like the humans always in the loop, but it was part of a hackathon, was it? That it started, they did the work?
It was like kind of a private hackathon,
a
right?
private hackathon, yeah. So you had the expertise, but also you were able to do the process mechanically as you needed. Like you were able to pick and choose what you wanted to. Let me take a quick look. I just had another question about the specific processes that you just ran. And before I ask that question, Alfredo, thank you for asking that. If I were in an organization that needed to make some modernization away from COBOL, or be it for resources, for talent, or for whatever reason, and sort of the first steps, obviously there isn't a single click way. You told us that at the beginning. Whoever's selling you that snake oil, you need to get your money back, because there is no way to. We're not there yet. Honestly, I think humans are always going to be in the loop, so there might not be a future where we're actually there. This is just moving too rapidly forward. But typically, the way that you will handle a modernization project of like this scale, you're talking about, I don't know, hundreds of hours of just the prep portion of it, right?
Yeah.
With the way that you structure sort of this 3-step or like 3-tier path to modernization, you're kind of laying all that groundwork. And then you can go in and figure out what's truly important, like what you actually need to focus your engineering resources on. So I don't know if you're able to share in terms of like the time that they saved, or what's this like the path to tackling the modernization specifically for the customer experience that you have, or any others where you're seeing that maybe that's something that was so deep in the back corner of where never maybe get to it, but never. Did that change bringing it a tool like this, and are more organizations doing things like this that are so like specific to like upgrading their core systems, and whether it be migrations to Java or just for whatever reason any other kind of modernizations that they need to do?
So the problem with COBOL is actually like a severe one, because the people who wrote COBOL like 60 years ago, they are dying, right? So
Yeah.
the problems are like they're like they have like severe problems that they now actually have to do something. A lot of the big organizations I talk to, they're always like, yeah, legacy modernizations doesn't really already or immediately add value for our customers or for ourselves, so we just not do it, right? We can generate new business features and new kind of applications, so we will just not do that. So a lot of organizations are now like in severe problems, and that they need to solve this problem. And although Bank Data is currently the only one who actually actively worked with us and provided us also code to test on, we are talking to a lot of customers around the world actually, who are now trying to solve that problem. And a lot of these organizations also, they want to stay in control of their modernization, because what's usually happening, right, especially when you're working with Microsoft, what we really like to do is to bring you a partner to solve all your problems for your modernization, and hopefully this application in the end running on Azure. But what a lot of customers do not want to actually give all their intellectual property like 100% to a partner anymore, right? They want to keep it in check. And this is also like one of the reasons why the Bank Data guys were eager to work with us, because they were also like, hey, we want to stay in control of our modernization approaches. I cannot really share, because it's obviously confidential, how they continued working with that, but we know that they continue working with that. They are also frequently giving us feedback about cool new features they were thinking about, and oh no, an error. And this is actually how they continue working. And we know, as we see, as our project get more and more forks, that also other people are trying to picking up at least the idea of if we could maybe chunk down our mainframe application or our mainframe into smaller chunks to actually feed it into like an application, or in this open source framework, also in a combination of AI assisted coding tools like GitHub Copilot, who is a great, I showed you earlier, or something else in combination with this kind of with this framework to actually continue working.
Specific to this project, I had a question about what dialects of COBOL were used for testing. And I think this might be someone that's actually has, like this is very specific to them. And I am so sorry, I can't find, oh, here we go, Alfredo's. Yes. What dialects of COBOL were tested? If we can get to that. And then I have another question coming up about how more in reference to the kernel itself and how the skills are selected for the particular task. But do you know specifically for this project?
I'm not a COBOL expert, right? So I say we tested core COBOL. For other dialects that I know of that we have been asked to test, but we did not have like the resources to test it, was like PL1. And we also were asked, what about 6, which is some kind of don't shoot me if I now say it wrong, right? Which is some kind of a middleware for a mainframe. We have also been asked if we already tried that, but no, we only worked with like the COBOL, the original way of COBOL, if you want to say it like that. But we would be eager to try it with something else.
Okay. And listen, folks, this is a open source project, right? Like, so you can go and do your fork and maybe contribute to it. And we are going to get all of these links. Actually, I think I'd love to get a link to the blog post as well. And I look for it, Julia. Yeah. But if you have it handy, if you could pass it to me, then we can go ahead and share that. Because I think that tells the full story, and the links to all the repos and everything will be there as well. Then we have a question about security. And I think super important beyond the control of the data, like you mentioned, so important for organizations to maintain. They definitely don't want to, we're talking about financial institutions, like what higher stakes could there possibly be, right? But when it comes to the cemental kernel and the way that is handling data privacy, just based on your experience in these projects, like are part of the instructions, how are they handling ensuring that sensitive information is not being sent? Or how does that work?
So when we are using an LLM that is hosted in the cloud, obviously we send information to that model in the cloud. But obviously, I'm showing you here a showcase with a model hosted in the cloud. But if you're like very eager and you're very sensitive with the data that you're actually using, you could obviously also host your own LLMs on your own infrastructure and just using this kind of program against your own endpoint. So semantic kernel is just an SDK. It does not handle any data at all. It's just a stupid SDK helping you work with the agentic or like the agentic orchestration. So if you have data that absolutely are not allowed to get into the cloud, you can prevent it by just using your own LLMs.
Fantastic. And now there is, I mean, hundreds of LLMs that you can also fine tune and run locally if
Yes, absolutely. I mean, also open source LLMs, right? I think OpenAI just also released open source LLMs. I was also on vacation. I only read about it. I haven't tried it yet.
Lady, we got a lot of catching up to do. Yes. And there is, I believe there is a mini version of it as well, the GPT OSS. So if that's definitely a concern, that's something that you can control by running these models locally.
Absolutely.
Wonderful. All right. And then there's a question from Aisha, and this is a great question about cloud platforms. And I think you touched base about it a bit at the beginning, like when using these modernizations, like obviously you showcase Azure. Hello, friends, we work here. we want to keep our jobs. But then you also shared that there was an AWS example that had been maybe integrated. So I guess this is kind of subjected to like, it depends. But I don't know if there is any empirical or like just any like from your experience with organizations. I don't think does it lean more one way or the other. Does it matter?
I haven't really seen imperial statistics about that, right? But a lot of like a lot of financial institutions are actually working with Azure. So my educated guess is that a lot of them are actually on Azure, but I know that the colleagues from AWS were also providing like this COBOL sample on GitHub publicly. They have also like an offering to do mainframe modernization, but it's completely proprietary. So you would have also hand your code to the AWS colleagues, I guess. I don't know a lot about this product. I just read about it. But yeah, from what I see and when I talk to other customers, it's either Azure or the AWS. I haven't seen anything from GCP yet, to be honest.
Okay, well, there you have it, friends. So I guess it really depends. But you now understanding that obviously Microsoft is heavily invested in optimizing the way that these practices are done. Like it sounds like Azure will be the right partner, and that's my advert for the day.
I am biased, so obviously Azure is the way. No, but really,
I love that.
But I mean, really, it is true for all software solutions. Is it a cloud? Is it an SDK? Use what works good for you, right? If you're good with AWS, use AWS. I haven't said that, right? Now it's on a recording. If you're good with Azure, use Azure. If you're good with .NET, use .NET. If you're good with Java, use Java. If you're seasoned with Kubernetes, maybe that's your way to go. If not, maybe an Azure App Service would help you. So it really depends. Choose the right technical solution for you.
100% I'm team do use what makes you happy and what makes you work the best. And then I have a question because there is a couple of modernization VS Code extensions that were released. I don't know if there have been GA yet. I was actually writing something for the Java one. That is there is a modernization tool that's just core to VS Code, and it's gonna be I want to say it's an extension you install. Same thing for .NET. So obviously there is investment in that space for us to provide these tools as open source. You can then help contribute to the extension. So if you want to experiment with this, obviously you can take this project, but then know that there is also work that's being done behind the scenes to create pathways to make this as simple as possible, because it's a very complex problem.
This is actually it, right? The GitHub Copilot app modernization for Java. I recorded a video about it on my LinkedIn. So if you want to see
good. Yeah, it's very good. Listen, friends, like, I mean, it took like I was opening things from like 2016 and trying to do a jump from like Java 8 to like now. And it did a good job. But I think with your project though, I mean, obviously it's not apples to apples, it's different. Yeah. But you're doing a lot more of the heavy lifting mechanical work that an actual, like you're taking it more in step of what like an engineer would be. It's not
Yeah.
so high level. These are the things that you should bring into whatever current dependencies, or these are the things that you don't need to use. It's actually doing like business analysis, and you have different agents for different things. And I like the orchestration of it, how it's actually giving you like a clear pathway
Also
to
the
a full
difference,
modernization.
yeah, the difference to the Copilot upgraded system for Java and .NET is that they are based on modernization rules that we already know, right? So we know what we need to do when we are coming from Java 8 to Java 21. And then we have like this AppCat modernization library, which is like super deterministic. We absolutely know what to do. We just need to hand the AI the rules to actually do that. The difference here is we have no idea what we actually have to do, right? So we have a rough idea, a strategy, right? How I wrote it down into my slides.markdown. But actually, every COBOL code, and this is true for every code, right? Every code is different, and it's also every COBOL code is even more different and even more complex. And the higher in complexity we get, the harder it is to actually get it in control, right? So creating clarity is a lot of my work, but actually I have no idea how to actually create good clarity with COBOL code. But maybe with these steps and a sophisticated multi-agentic approach to actually tackle this problem iteratively.
Fantastic. All right. Let me take a look through the chat and see if there is any other questions. And Franks, please feel free to post your questions for Julia. Julia, this has been so informative. Like, I've learned a ton. I can't wait to give it a go. So let me find the open source repo that's out now. And then you're gonna share your prompts with us, correct? Or is that part of that?
I can totally share. Let me share my screen again, so I can also like show you the repository. Where is it?
That'd be amazing. It's a legacy modernization agents.
Yeah,
I think
there it is. Yeah, this is the repository, legacy modernization agents in Azure Samples. Or short aka.ms/COBOL, and there you can basically find. I will push the prompt in a bit immediately after the stream, so that you also have them. But this is basically like the whole breakdown, what we are doing, how you can actually use it, how to use the doctor.sh file. We have like a full flow diagram. So if you're into diagrams, we got you. There you can see what we're actually doing, what the agents, how they are currently prompted, what you can actually do. Also, Gustav took a lot of effort into actually document the program itself, so how the modernization agent orchestration are actually working. And I know I need to reshare my screen again because I'm unable to use StreamYard properly.
You're okay.
We also wrote a blog article where you can have like the full rundown of what we're actually doing, which you can find under aka.ns/COBOL-blog, where you have like more thorough information. Here we go deeper also in like the preparation steps we talked about earlier. We also talk about our first iteration of what we actually wanted to do with Autogen, and also give some guidance on how to do like the prompting for the agents. That could be also be a guideline when you want to write your own agents or prompt your own agents, how to actually approach that.
Wonderful. And so if we go the samples repo, obviously this is all open. You can go ahead and fork it, and then you'll have everything there. And then Julia kindly offered to push the prompts later as well.
Yes.
And then go read the blog post so you can get like sort of a historical context of and the actual example of the organization that you partner with to work on this project. Is this something that if I'm an organization that are watching you right now and like you're like, I want Julia to work on this with me, like can they reach out to you? Like can they reach out to their account managers? Like I feel like that's the secret sauce. Have you come over, do a private hackathon and
so when you are in an organization that's already in contact with Microsoft, contact your Microsoft account management and they will reach out to us internally. So this is like the most direct way. But obviously you can also open an issue in the GitHub repository if you want to, and we can try to reach out of that. Or you can obviously ping me and Gustav on LinkedIn, and we will try to get in contact with you to try to find out how we maybe want to collaborate. And how to work together further.
That's amazing. Wonderful. So you heard it here first. If you're watching this and you're like, okay, yeah, this all sounds great, but I don't have the time to dig into all the details and I just want to partner up, then find your partners. Amazing. All right, friends. Well, we're coming up to close. And Julia, you've been so generous with your time. I appreciate you. I don't even know. I probably lied to you like I do to all my guests. I'm like, it'll take 30 minutes. And here we are an hour later. But thank you so much for being so generous with your time and with your knowledge here today. And a shout out to Gustav, your partner, in getting this going as well. Like obviously this was a very complex and well thought out process. And like,
Yeah.
thank you, thank you.
We are very proud, actually. We are also very proud that we got the time. It was some kind of a side quest that then, in terms of time, became like a main quest while it still was a side quest. So we were working really hard, and we're also very thankful for the customer who actually working with us together on that. And they also spent their time with us on this like crazy project and crazy idea that we had. Yeah, thank you for inviting me, Andrea. It was so much fun. Thank you for giving me the stage.
No, my goodness. Thank you. And so I'm going to share, I have shared on the chat, the links, but then later on today, I'll go ahead and edit the descriptions for this if you're watching us on YouTube. So you'll be able to click on all the links right there. Go ahead and give Julia a follow so that you can see her feed. So when she's sharing like amazing blog posts like this, how we use AI agents for COBOL migration, you have it first class and you have it right there and ready to learn. And then Julia, if someone wants to contribute to the samples, all they gotta do is just go to the repo and I guess they can fork it and then
fork it, open an issue, open a pull request. Feel free to do whatever you would like to do. We would be very happy if we would get collaborators on that.
Amazing. So for all of you unicorns out there who are still clicking away and have an amount of expertise in COBOL that no AI can match, please join this effort so that we're kind of paving the way. Again, it's not that y'all gonna live forever, but your code can in perpetuity. So that's awesome. Awesome. Julia, where are you gonna go next? Is there anything coming up for you? Any conference talks? Any travel? Or is there anything that
the next
done
time
recently?
I will be at Porto Tech Hub. I think it's in October. So I'm invited and we'll talk about platform engineering and AI and also how to tackle legacy modernization. So when you're at Porto Tech Hub in October, I'm happy to meet you there.
Amazing. And I can tell you, friends, from in-person experience, Julia is very nice. So if you see Julia, you feel free to say hi. Like, listen, sometimes they say don't meet your heroes, but that wasn't the case. It was lovely to meet you. So amazing. All right. Well, friends, if you come through this stream after we close out and have questions, follow Julia on LinkedIn, share it on social and at me or send us a message. And I'm sure we'll be happy to connect you with the right folks. If you go on to experiment and bring some of these modernization practices into your own organizations because you watched this stream today, please let me know. I think that will make all of our days, knowing that something we put out was actually helpful. Thank you all so much for being here. Julia, you're amazing. Is the Portal Tech Hub? Is that the name of the conference?
Porto, like the city in
Porto. Oh, lovely. Oh, nice. I tell you what, European tech conferences, man. That sounds really amazing. That sounds really, really amazing. So listen, if you happen to be in Portugal or if you have a very generous company that has a lovely travel budget for you to go to Porto Tech Hub. Off you go. All right, Julia, thank you so much. I'll see you next time. When are you coming back? I miss you already.
I know. You need to invite me, I guess.
Listen, once you're done with this Porto Tech, we'll plan for, I love to put this to the test and maybe find some other projects. If you have, Porto, thank you, Jorge. If you have a project that you think will make an interesting test for this framework, like bring it to us. Maybe we'll do it live. We'll do like a little hack section. We can do as part of our Robert Duck Thursday sessions. I think that'd be fun.
That would be amazing.
Yes. Julia, you're a star. Thank you for being here.
Thank you for inviting me, Andrea.
How much did we learn? All the things. I am so excited to dig into this. And this was indeed an amazing session. Thank you so much for everyone that joined. Thank you for your patience while we get kicked off at the beginning. And if you do end up reaching out to Julia, follow, trying the Azure samples. Friends, there is a ton of very, very, very interesting stuff in these Azure samples. So if this is a repository that is new to you, I'm going to go ahead and share it again here in the chat so that you can, on your own time, take it for a spin. But thank you all so very much. I have shared Julia's social. I believe she would like to connect with people via LinkedIn. So you can, once again, find Julia at gh.io/Julia. And I want to say I'm at gh.io/Andrea. I mean, that might take you to my GitHub. That's got all the things. Thank you for being here, friends. And we'll see you next time. If you have been using any of these tools again, in any of your projects, please let me know. Add me on social. And if you want to see something in this vein of topics, please let us know. Please let us know. That's what we're here for. So I'm going to leave you again with my most favorite new little jingle that we have. And don't forget to join us tomorrow for Robert Duck Thursday. We're going to do 3 streams, one early for the European folks, and then midday, and later in the day in Portuguese and Spanish. And on Friday for Open Source Friday, this Friday, I will be hosting the Secure Your Code game, which is an initiative by the GitHub Security Lab. And we have 2 of the core contributors to that amazing, amazing project here. So we're going to go over their motivation to create the game and actually demo it live. So I hope to see y'all on Friday. Thank you for being here. Appreciate you.
I want it, I get it.